This was a very nice start to get our brains and bodies thinking about dynamics. And now I think Johan Rockström, who is the director of the Stockholm Resilience Center and also director of Stockholm Environment Institute, will exemplify and discuss some of the insights from Buzz's work on the challenges we're facing on the globe as a whole. It's great, Johan, that you will do this half an hour, 20 minutes for us.
Thanks, Kalle.
Okay.
And thanks, Buzz, and congratulations. We are in awe, of course, for all the work you've done. And what I'll try to do is more of an exploratory journey to share with you some of the concerns and also some of the research challenges that we think lie right at the front when you try to lift up the theory of resilience all the way to the planetary level. And there's good reason to take that challenge on because, as Professor Will Steffen pointed out, at the Resilience Conference, the first scientific resilience conference held here in Stockholm and hosted by the Academy and the Stockholm Resilience Center and ICSU in April and the Resilience Alliance, that we are in a very turbulent time. And no doubt is this reflected, as you point out, Buzz, not only in the big global environmental crisis, as the Nobel Prize laureate Paul Crutzen points out, we are now in the Anthropocene, where we as humans are the dominating new driver of planetary change to the extent that we can talk of a new geological era. This turbulence, of course, means that I fully agree with you, Buzz, it's a great day for the planet. Obama and Buzz on the same day. which of course, is something, if the planet would have been with us today, would have been dancing probably as the whole African continent is doing right as we speak. And this is, of course, something we start seeing proof of. And in my mind today, this is probably the most important line of all categories. And I can tell you it's not the drop of the Dow Jones Index over the past couple of weeks. It is the dramatic threshold of ice melt in the Arctic. And what is so dramatic with this is not only that it's a warning signal to humanity that the Arctic ice sheet has crossed the threshold, it also shows that science has blissfully failed. Nobody has been able to predict, with all the power of the models that we have, even in the worst case scenarios of the IPCC, this was predicted to happen in 50 years' time. And suddenly we see complex dynamics pushed from complex multiple drivers, a threshold effect, and a much more precarious situation than we previously thought. Is anyone reacting to this in a sustainability or resilience paradigm way? No, we're just patching an incremental change and actually even planning how to exploit this new potential fossil fuel resource in the best way. As Buzz pointed out, we've seen it before in the collapse of the cod fisheries. We know that just outside the door here, we have another system that may have actually been pushed in the same way, the Baltic Sea, flipped through multiple pressures of social, ecological drivers, put in a state that we, unfortunately, as Swedes know all too well now, stuck in a new undesirable state where it doesn't really matter in the incremental change paradigm of command and control we apply today. We don't seem to get it out of that undesirable state. It happens in the social domain as well. We know that probably the first government on the planet has fallen on the climate issue. In Australia, 7 years of consecutive drought gets a whole population across the threshold. Prime Minister Rudd comes in and signs the Kyoto Protocol as the first task in office, a major threshold in the social system, which of course many of us hope could happen also in the financial crisis, a constructive opportunity to use the crisis to revisit the Bretton Woods institutions and realize that the financial crisis is closely linked, of course, to the environmental crisis because it's all about excessive consumption in the end. Now, this can be represented, I mean, the dire state we're in, the Anthropocene, in the quadruple squeeze on the planet. And it really starts with the drivers of the human growth, which is not only a population issue, it's really the fact, the cynical, unfortunate fact, that it's 20% of the wealthy that have caused the bulk of the problem, and we know that 80% have not contributed, but they aspire to our lifestyles. We also know that we have the 350, 450, 550 dilemma of concentration of greenhouse gases in the atmosphere, where the IPCC and the climate negotiations talk of 450 ppm of concentration of greenhouse gases to be the safe level to avoid 2 degrees plus warming. But more and more science shows that when we start understanding the complex interconnectedness of the Earth system, we probably have to head much, much lower, 350 or below in order to avoid dangerous tipping points. We are already at 385 in CO2 and probably 450 in CO2 equivalent. But the International Energy Agency points out that we're heading very, very rapidly and unfortunately decisively towards 550. China builds 1 coal power plant a week, size equal to 1 nuclear plant in Sweden. So that dilemma happens, unfortunately, on a planet which is losing its resilience very, very rapidly. At a time in human history when we really need a resilient planet, the Millennium Ecosystem Assessment shows that we have deteriorated ecosystem functions and services, which stands behind not only human well-being, but the capacity to buffer and withstand change more rapidly than ever. And then comes buzz theory and science, so well proven by a number of scientists in the world, showing that we are not at all in a mode where things move incrementally, linearly, and controllably. 99% of change occurs in 1% of events, as pointed out by Steve Carpenter, again at our April Resilience Conference. So all in all, a much more complicated and a much more tough challenge than we previously thought. Now, this has all been contributed, this understanding has been contributed to by the understanding that we have nonlinearities in multiple states. Buzz has already gone through that very detailed. There's very impressive empirical evidence that this occurs, but most of the research has been done, admittedly, at the local or regional scale of primarily not so anthropogenically impacted systems on the system itself, such as coral reef systems, lake systems, grasslands, impacted from the outside, but not in themselves. But very clearly showing tipping points through trigger effects and getting stuck in undesirable states. The question then is, how does this scale up, and is there an agenda on the global level? But just before taking that step, to share with you, well, so what is resilience then when we look at it in these systems that have been studied so far? Well, much of the research has focused originally, as Buzz points out, in the persistence, the ability to withstand disturbance and stay within a desired state and to avoid state change. But the way resilience thinking has evolved over the decades also includes the much, much broader realization that it also has the qualities of adaptability and also increasingly importantly, the capacity for learning and transformation, the ability to take on a crisis head on and not patchwork within a system which is bound to continue failing, but rather to innovate and renew. We see more and more, interestingly, applications of resilience thinking in the real world. You may have seen that the World Resources Institute in its latest World Resources actually take on resilience as the basis of its overview of the world resources. We see applications from the Resilience Alliance, not only in communicating, but also in operationalizing and integrating it into, for example, catchment management in Australia. We see that the whole Green Revolution International Agricultural Research Organization, the CGIAR system, is taking on resilience thinking in its next phase of work on water resources and development. In the follow-up of the EMA, in dialogue with the private sector, in reviews of ecosystem services, more and more of nonlinear thinking is entering that paradigm. And the important study released just last week as one part in a larger project of the European Environment Agency on the economics of ecosystems biodiversity, even there we start seeing elements of understanding the importance to withstand and safeguard biodiversity as a resilience measure, as a tool to avoid threshold effects. So interestingly, the science is moving on into the governance and management domain. A very interesting example, known to many in this room, of course, is the resilience inspiration of the new way the Great Barrier Reef is managed. The realization that functional biodiversity in terms of sustaining predators to avoid overgrazing is a key of the resilience of the system, and the large no-take zones in the Great Barrier Reef is an example of application of resilience in the real world and a success story. So then the question is, does this have relevance across scale? Does resilience have anything to tell us at the global scale? Well, I think to take ourselves into that journey, it's logical to start in the interactions of the big systems, the interactions of the big interacting subsystems of the Earth system and their implications on nonlinear dynamics. And one way to start this is, in my mind, the very dramatic evolution of greenhouse gas emissions on the planet. And we know this curve so well from the 4 gigatons of carbon we emitted in the 60s, and in all honesty, the complete failure of the Kyoto Protocol in abating the pace of this change. As you see, it's actually escalated in the past 10 years, and the 9 gigatons we're emitting today. This is what has caused 0.7 degrees Celsius temperature rise, and this is what is committing ourselves not far from 2 degrees. But is it this concentration in the atmosphere that is causing the warming? Well, no. Luckily for us, no, because 25% of the emissions are absorbed by the oceans and another 25% by the terrestrial ecosystems. So basically, we have the world's largest free ecosystem service operating, showing that the planet Earth in itself has a tremendous resilience to keep itself and self-regulating within a desired state, and that the net effect on warming is just half of our emissions. Unfortunately, this work by the Global Carbon Project shows a very disturbing trend, that the proportion of sequestering today is smaller than the proportion of sequestering in the 60s, suggesting that we might see the crack in the stability domain and an initial phase towards a reduced ability to sequester greenhouse gases, which could be the variability sign that we're approaching tipping points, which of course would lead to uncontrolled accelerated global warming. This has led John Schellenhuber, the head of the Potsdam Institute for Climate Impact Research, to look into the risks we're facing under business as usual of large tipping points in the subsystems of the planet. And here we have, for example, the instability of the Greenland ice sheet. Very few think that we'll lose the Greenland ice sheet, but one should remember that even 20% melting of the Greenland ice sheet is several meters of sea level rise on the planet. And we know that the scientists at the Ilulissat ice fjord in Greenland cannot understand the accelerated dynamic of melting which they see observing right at this moment. We see for the first time in 10 years accelerated methane outbursts. Swedish scientists, as part of a project, where suddenly and unexplainably a very large increase in flux of methane. And we know from research of Carl Norbers and others linked to the IGBP here at the Academy that we cannot anymore exclude that the Amazon rainforest, under multiple pressures of temperature rise and logging, may be into a dynamic process towards a savanna state, which in itself would have dramatic effects at the larger regional global level. So is it so that we can take the resilience theory of multiple stable states up to the planetary level? Well, at least it appears, when discussing this with global change researchers across the world and the Earth System Science Partnership under ICSU, that yes, there is probably a reason now, unfortunately, under the pressures of the Anthropocene, the pressures that humanity is kind of kicking on hardwired ceilings on the planet, that this may actually be relevant. And not least the Vostok ice sheet suggests this, because we know that the planet over the past half billion years, has had a tremendous and extraordinary ability to self-regulate itself within very, very narrow, fine limits of gases in the atmosphere. And if I had had Al Gore's elevator here, I would have been up in the ceiling, as you know, to point out the dot today of carbon dioxide in that half-billion-year trend. Now, we know that the pressures are tremendous. We have the hockey stick pattern of carbon dioxide up in the left corner. We normally just focus on that one. But it doesn't matter which indicator of human well-being linked to natural capital we take. They all show the same accelerated pattern from the 1950s onward. This is the human enterprise accelerating into the Anthropocene. Science, admittedly, does not know what happens when these hockey sticks start playing as a hockey team. That's the drama. That's why it may be relevant to address resilience at the planetary level. Things are happening already today. We see water resources declining already today as a result of global environmental change. In red, reductions in runoff. We know that we have social thresholds potentially around the corner when you start doing these kind of analysis, where you see the African hunger belt, and in gray here are the semi-arid savanna zones, the most vulnerable regions already related to inherent water resources. In dark green, the countries that have to more than double freshwater use just to reach the Millennium Development Goals, just to halve hunger in 8 years. And here the IPCC fourth assessment, if we go on in business as usual, up to 50% reduction in food production due to climate change. But look at the correspondence here between climate change vulnerability, social demands, and inherent vulnerability. A cocktail of potential disasters in weak economies. This is, of course, something that has to be put into the picture when addressing resilience at the larger scale. So are we here? Are we actually pushing the planet towards a place we don't want to be? Because you don't want to stand too close to the foam of a threshold, as this gentleman is doing. And increasingly, we're trying to, within the Resilience Center, facilitate a process to say, do we have safe fences we want to put up at the planetary level to avoid, to govern for resilience at the planetary level, to avoid coming too close to tipping points? And these are increasingly important, not only because of that very, very pressure acceleration, but due to this dynamic where we know that with increased wealth, here in US dollars per capita, food, energy, water, whatever parameter you take, it accelerates very rapidly when wealth increases and doesn't stabilize until you are at a very high level. 80% of the world population is down here. 80% of the world population is at the rapid escalating phase of a right to development. So the pressure is a momentum which is much larger than we had in the 50s. So this, of course, means that it may be time to start exploring what are the safe boundaries at the planetary level. This is ongoing research work. We've tried to identify where could these be? Because so far we only talk about climate. What is the safe concentration of greenhouse gases? But clearly we start seeing other interconnected parameters such as ocean acidification, aerosol loading, ozone depletion, but also our manipulation of the big, big cycles on the planet. And these together are so interconnected that we have an hypothesis that they have a kind of a three musketeer behavior. One falls, other falls. We have to probably be guardians of them all to keep the planet on a resilient pathway. It's possible to start monitoring these over time, and we can see already in the 60s how we transgress terrestrial biodiversity and the manipulation of the nitrogen cycle. You see that carbon dioxide doesn't until the 2000s cross the safe boundary of 350 ppm, which we've suggested. The ozone threshold was crossed but returned back thanks to the Montreal Protocol. And today we are in a quite dire state when it comes to a number of these boundaries. And some of them we haven't been able to quantify even. So all in all, we see a situation of greater complexity. And just to share with you one example, so if we have the safe boundary on ocean acidification, which absorbs 25% of carbon emissions, we know that pH is lowering, so we have to probably keep the carbonate ions concentration at a level which we believe is in the order of 200, 250, which is okay if we have a high level of grazing of the world's coral reefs, because that keeps the ability of the coral reefs to absorb carbon. But see what happens that when the grazing pressure is reduced because of overfishing, probably this boundary will move and will actually reduce the safe space. If then we continue with the eutrophication and continue to transgress the nitrogen cycle, the safe space reduces even more, meaning that the interactions between coral reefs and land use weakens the resilience of the ocean system and reduces the planetary safe space to continue securing absorption of carbon dioxide in the oceans. So example of three boundaries interacting and the complexity around needing to guard them all. I'm very soon finished here. Don't worry. So, finally then, what are the implications of this for humanity? Well, one could, of course, spend a long time discussing this, but I think it is time to be quite clear that we are not anymore in a phase of anthropogenic climate change. We are rather in a mode of anthropogenic, abrupt global environmental change, and that we have nothing less than a resilience crisis around the corner, which is, in a sense, going parallel with a large financial crisis. And this will not only require adaptation, but probably also transformation and renewal. We have to truly rethink the way we relate to nature, the way we place ecosystems as the core for social and economic development. And as an ending, this might be, as Buzz points out, a unique phase in human history. And this is a graph developed by Roger Casperson, whom I know is with us today, of the growing velocity of big transformations that we've seen in the recent history of civilization. and that we are now clearly moving into a new phase, a planetary phase, the Anthropocene, the pressure of humanity on the planet, which is larger than ever. And then the question is, and sharing with you just as an hypothesis, is it so that we're seeing a transgression of one adaptive cycle up to Linné and Newton, when we left the theological phase behind us and went into the rational phase, and then the industrialization, as Buzz points out, moving into the capitalist era some 75, 100 years back, when we start seeing the escalation of the pressures on the planet. We enter the Anthropocene, and are we perhaps seeing the start of the ecological era, a new phase in humanity, which of course appropriately today should probably not be called the ecological era, but the Buzz Holling era. Thank you.